Hi guys, so today we are going to use everything that we learned last week to do one thing called exact values. And exact values are probably the most important thing we're actually going to do this year in pre-cal, because you're going to see them a ton in calculus. And the more familiar you are with them and the faster you can do them, the easier it's going to make calculus for you. So the way we're going to do these is we're going to start by drawing a picture. So what I'm going to do is I'm going to find the sine of 30 degrees. Now, in geometry, you actually did this, but you used a calculator and you got decimal answers. So you went to your calculator, changed your mode, typed it in, and got some decimal. So what we're going to do, because we don't like decimals, we don't want to round, we're going to draw a picture to find what this is exactly. So I'm going to start by drawing a 30-degree angle. I know a 30-degree angle has its terminal side in the first quadrant. And I know that the reference angle there is 30 degrees. Now what I'm going to do is I'm going to take this and I'm going to turn that into a right triangle on the x-axis. So I know if that's a 90-degree angle at the bottom and a 30-degree reference angle, that missing angle has to be 60, which makes this a 30, 60, 90 triangle. And it's really hard to see that 60 there. Let me rewrite it. So if this is a 30, 60, 90 triangle, I can fill in any numbers I want as long as they fit this ratio. And the easiest numbers for me to pick is if I plug in 1, root 3, and 2. Then once this triangle is all filled in, all I need to do is find these different values. So for example, the sine of 30 degrees, that's the opposite over hypotenuse on this triangle. My opposite of 30 is 1, and my hypotenuse is 2. So the sine of 30 degrees is 1/2. Now let's say I want to do the cosine. Okay, so if I want to do the cosine, then I'm going to look at that same triangle. I'm still looking with my reference angle of 30, but I want the adjacent side over the hypotenuse. So adjacent over hypotenuse is going to be root 3 over 2. And if I were to take my calculator and type in the cosine of 30 degrees, it's going to give me some decimal like 0.866. If I were to type in the square root of 3 divided by 2, I would get that same decimal. So this is just exactly what my answer is without any sort of rounding. And then finally, if I do the tangent of 30 degrees. So the tangent is my opposite over adjacent. So I look at that same picture and I just plug in my opposite side over my adjacent side. And remember, it's okay to leave that square root in the bottom of the fraction. So that's the basics of exact values. Now what we're going to do is we're going to see what happens when it's not in the first quadrant. Okay, so we're still going to do some more with degrees, and then we'll do some with radians. So the first one's going to be the sine of 120 degrees. And I'm going to start this the same way. I'm going to find the terminal side of a 120-degree angle, and that's going to fall in quadrant 2, because I know it's 180 to this point, and it's 120 there. So the next thing I need to find is my reference angle, so that in between section, if it's 180 all the way to the line, I've got to have 60 degrees in between. Then I'm just going to turn this into a right triangle, and I just lost my picture. And my picture's back. So now I know that, again, this is another 30, 60, 90 triangle, and I'm going to fill it in with those same basic ratios. Across from 30 is 1, across from 60 is root 3, and across from 90 is 2. The only thing I need to add to this picture is a negative. So if you were to plot that point over there, if I'm going side to side, back on the x-axis, I'm moving in the negative direction. Those are negative x values when I plot those points. So that means that 1 has to have a negative in front of it. Now that my triangle is completely filled in, I can find my ratios. So I'm looking for sine. Sine is opposite over hypotenuse, and that's going to be root 3 over 2. So technically the negatives didn't change that, but it is a good habit to get into. Make sure you don't forget about them. Now we do the cotangent of negative 135. Again, I'm going to start this the same way by drawing my picture. So a negative 135 degrees is going to be backwards and end in quadrant 3. That would be my negative 135. So I drew my angle. I need to find my reference angle. It's 135 degrees to that point. It's 180 to the line, so that in between is 45. Then I make my right angle. And if you notice, I'm making all of these right triangles with the x-axis. And that's what's so important. It's always made with a horizontal line, just like our reference angles were. So I drew that with the x-axis, and this one's 45, 45, 90. And again, I just need to follow that same ratio. Okay, it's x, x, and x root 2, which means I can fill that in with 1, 1, root 2. I need to add some negatives, so I'm going in the negative direction on the x-axis, and I'm going in the negative direction on the y-axis. And once this is filled in, I can find my values. So cotangent, that's adjacent over opposite, which means it's negative 1 over negative 1, which is just regular old 1. Alright, now we're going to take the same idea, and we're going to use radians. Now down here I went ahead and wrote the steps that we've been using for all of these. So if you want to write those down, you can, but that's just the steps we've been following for every one of these exact values so far. Now radians are actually really nice to work with because the reference angles are really easy to find. Every pi over 6 radian value we have, as long as it's reduced, every pi over 6 radian value is going to have a reference angle of pi over 6. So whether it's 13 pi over 6, negative 7 pi over 6, 26 pi, or actually that would reduce, so 25 pi over 6, those would all have a reference angle of pi over 6. Alright, same thing with pi over 4. Pi over 4, as long as it's reduced, is going to have a reference angle of pi over 4. So 11 pi over 4, 7 pi over 4, all those would reduce to pi over 4. And then the next one is pi over 3. So 2 pi over 3, negative 5 pi over 3, those all have a reference of pi over 3. So the only thing that we have to remember is what the corresponding angle measurement is for those three, because these are the most common ones. Pi over 6, if we forgot, we can always work it out. I could multiply by 180 over pi to get 30 degrees. Same thing with pi over 4, that works out to be 45 degrees, and pi over 3 works out to be 60 degrees. And again, something that makes this a little bit easier, pi over 6, that's 1/6 pi, which means 1/6 we know is smaller than 1/3, so that has to be my smallest angle. So pi over 6 is the smallest angle. So now when I do the cosecant of 11 pi over 6, I'm going to start it the same way. I'm going to start by drawing 11 pi over 6 in the right quadrant. I know this is 0. This is pi, which with the common denominator is 6 pi over 6. And then all the way around would be 2 pi, and 2 pi is equivalent to 12 pi over 6. So that means 11 pi over 6 has to fall in this fourth quadrant. I draw my triangle with the x-axis, and I know my reference angle is pi over 6, which we know is 30 degrees. So any pi over 6 radian value has a reference angle of 30. Once I have that 30 filled in, I can just fill in the rest of my triangle. Across from 30 is 1, across from 60 is root 3, and across from 90 is 2. Now once my triangle is filled in, I got to fill in my positives and negatives. The only negative I should have is the 1, which means now I can find my cosecant ratio. Cosecant is hypotenuse over opposite. It's the reciprocal of sine. So hypotenuse is 2, and my opposite from my reference angle is negative 1, which means my value is negative 2. Now there's a couple more that I want to look at that are a special case, but before we do that, I want to look at our circle that we talked about a while back. Okay, so this was our unit circle, and we filled in all the degree and radian values on this circle. So the first thing I want to look at is, if you guys notice, all the ones that are yellow on there, okay, we noticed earlier they were all something over 6. Now what we can notice about all of those is they all have a reference angle of 30 degrees. All those red lines, originally we saw that they were all pi over 4, but now you can see they all have a reference angle of 45 degrees. And all the green ones have a reference angle of 60 degrees. So those are the common lines that we're going to see when we make our exact values. Now, what we also learned, we also talked at the very beginning about the sine, cosine, and tangent of 30 degrees. What this actually shows on my circle, if I were to plot a point right there at 30 degrees, if you remember, we talked about how the unit circle is a circle with a radius of 1 unit, which means that that distance is 1. If that distance is 1, then I can find the x-coordinate and y-coordinate of that point, and it's going to relate to my sine and my cosine. Now we learned that the cosine of 30 degrees was root 3 over 2, and the sine of 30 degrees was 1/2. those are actually the x and y coordinates of that point right there at 30 degrees if that radius is 1. I have to go over root 3 over 2 and up 1/2. Then if I wanted to find the tangent is actually my y divided by my x, and that's how I would get 1 over root 3, which is also what I found by drawing my triangles. So the cosine relates to my x-coordinate, the sine relates to my y-coordinate, and the tangent relates to the sine divided by the cosine. And we're going to talk a lot more about that this year, remembering which one goes with which. But we're going to use this to look at a couple things on this circle. First of all, because that's true, okay, we know over here then, at this point, those values are going to be the same. Okay, but the problem is there's a few things that'll change. So I'm going to fill in my value. I've got a cosine of root 3 over 2, a sine of 1/2, and I've got a tangent of 1 over root 3. What I do know is if the cosine is the x-coordinate, if I were to plot that point on a graph, what I would have to do, my x-coordinate would have to be negative. My sine is, which is my y, I'm going up in a positive direction, so that has to stay positive. But then when I find my tangent, I'm doing sine divided by cosine. A positive divided by a negative gives me a negative. So what that means is in my second quadrant, I have sine that's positive. Now using this and what we did on the back of last night's homework, we can find some shortcuts for double checking our answers to find the signs. And by signs, I don't mean S-I-N-E, I mean the positive or negative on it. So in the first quadrant, all of my functions are positive. Sine, cosine, and tangent were all positive. In the second quadrant, if you notice, because I'm moving in a couple different directions, we have that negative side to side, the only positive function there is sine, or its reciprocal, which is cosecant. Then I also know in the third quadrant, if I were to go ahead and graph that out or look at my homework from yesterday, I know tangent and its reciprocal, which is cotangent, would also be positive. And then finally in the fourth quadrant, cosine would have to be positive. And also its reciprocal, which is secant. So these letters help me remember which functions are positive in those quadrants. So they're all positive, only sine and its reciprocal, only tangent and its reciprocal, and then finally in quadrant 4, only cosine and its reciprocal. So to remember which functions are positive, I use all smarties take calculus. So it goes in that quadrant order. All smarties take calculus. And that's how I remember the order of what's positive in which quadrant. Now, as long as you draw your pictures correctly, you're not going to have a problem because you'll always mark those negatives. So this is a good way to help you double check all those values. What this also helps us do is it helps us to figure out my sine, cosine, and tangent for those angles that happen to fall right here on those border lines. So when these angles fall right on the border lines, I can't draw a triangle. Okay, so there's two ways that we can solve for these. One is by using what we just learned about the unit circle, and another is a little acronym we can use to help us out. Now on the unit circle, let's say I have this point here. Well, I know the radius of this circle is 1. So that means the coordinates of that point would have to be 1, 0. Well, I know my horizontal component is my x, which is my cosine. So I know 1 is my cosine, and 0 is my sine. That means my tangent would have to be sine divided by cosine, which is 0 divided by 1, which is 0. Then up here at the top, that point would be 0, 1, and then 1 divided by 0, when I do that, I get undefined. So that's my cosine, sine, and tangent. Remember, cosine is the x-coordinate. Over here at 180, that would be -1, 0, and then 0 divided by -1 is 0. That's my, I'm making it backwards on you. Cosine is my x, sine is my y, tangent is sine over cosine. Then down here at the bottom, I've got 0, -1. And then again, when I divide by 0, I get undefined. So that's cosine, sine, and tangent. So that's one way I can find my sine, cosine, and tangent for those border angles. Now the other way is a little bit easier for a lot of kids, and it's a little song that we can remember, or saying I guess I should say. And what the saying is, it's O-I-O, I owe you. Oh, I don't owe you. So you start by saying, oh, I think I owe you something, and then you're saying, oh, nope, I'm wrong, no, I don't. Now the way this is written, okay, I'm going to say it one more time, it's O-I-O, I owe you. Oh, I don't owe. I don't owe you. And a lot of kids are really good at remembering what this looks like. Oh, I owe you. Oh, I don't owe you. So the I don'ts are my negative ones, the yous are my undefineds. What you have to remember, though, if you're using this, is what goes on the outside. That's actually how I'm going to use this chart. I have to remember at the top, it goes in normal SOHCAHTOA order, sine, cosine, then tangent. And then down the side, I start at 0 degrees, then I go to 90, 180, and 270. And any others on the border I want to find, I can just find a coterminal angle. I also could write these in radians if I wanted to, and it would be the same thing. So then I just use this chart to figure out what these different values are going to be. So for example, if I wanted to find the tangent of 90, well, the tangent of 90 is undefined. Let's say I want to find the cosine of pi. So I look on my chart and I find cosine, and then I find pi, and I get -1. So the cosine of pi is -1. Now if you want to find one of your reciprocals, like let's say I want to find the cosecant of pi over 2. Remember, cosecant is a reciprocal of sine. That means it's 1 over the sine of pi over 2. So I find the sine of pi over 2, and then I take the reciprocal. So the sine of pi over 2 is 1. And then 1 divided by 1 is just regular old 1. Okay, what if I wanted to do one that was a 0? What if I wanted to do the secant of 3 pi over 2? That's the reciprocal of cosine, all right, and the cosine of 3 pi over 2 is 0, and 1 divided by 0 is undefined. So the secant of 3 pi over 2 is undefined. Then last, let's say I want to do the cotangent, not the cosine, how about the cotangent of 90 degrees? Well, I find the tangent of 90, which is undefined. But the problem is I'm doing 1 divided by undefined. Now the reason this is going to work out the way it is because the undefined, the reason we get it is because it's 1 divided by 0. And if I flip 1 divided by 0, it becomes 0 divided by 1. So the reciprocal of undefined is 0. So when I'm finding reciprocals, the reciprocal of 1 and -1 is still just 1 or -1. It doesn't change. But the reciprocal of 0 is undefined, and the reciprocal of undefined is 0. And that's all there is for exact values, guys. So what you need to do on these, remember, if it's inside those border lines, draw a triangle, find your reference angle with your special right triangle ratios. If it's on the line, you can't draw a triangle. You need to use either those coordinates or you need to use this little chart to help you figure it out.